Now, for a certain function f, the first derivative is given as f dash x or f prime x is equal to 3x squared plus 8x minus 3. Question 9.1, calculate the x coordinates of the stationary points of f. So in order to calculate stationary points, we must first get our first derivative and then equate it to 0. So our first derivative has actually been given to us. We don't have the original. So it's going to be 3x squared plus 8x minus 3. So they've done the hard work for us. We equate it to 0 and we solve for x. You can just plug this into your calculator or your quadratic formula. It's going to be 3x minus 1 in the first bracket and x plus 3 in the second is equal to 0. Therefore, x is equal to a third. Alternatively, x is equal to negative 3. Okay, and that's it for question 9.1. Sorted. 9.2, for which values of x is f concave down? So whenever we speak of concavity, we must always find our second derivative. So f double prime x or double dash x, whatever you guys call it. These are little apostrophes. You know, there's a bunch of names that are used at different schools. So second derivative, 3 times 2 is equal to 6x. 2 minus 1 is just 1. We don't need to indicate it. 8 times 1 is just going to be 8. 1 minus 1 is 0. Anything to the power of 0 is 1. So 8 times 1 is just going to be 8. And the derivative of any constant is just going to be and for which values of x is f going to be concave down? So here, it would be assumed that our a value was actually 0. So we're going to set 6x plus 8. It's concave down, so we're going to set these values to less than 0. Therefore, 6x is less than 8, and x is going to be equal to 8 over 6, which is just going to simplify to negative 4 over 3. Sorry, this positive 8 on the left-hand side, when you take it over to the right, it becomes negative. So x equals negative 8 over 6. And x is less than negative 4 over 3. And that is the question for 9.2. Let us have a look at 9.3. So just quickly take it down. I am going to clean. 9.3, determine the values of x for which f is strictly increasing. So we are going to utilize our answers from 9.1, our stationary points, and given that a is going to be positive, our values are going to look like this. So from negative 3, it's going to go all the way to infinity. So x is less than or equal to negative 3, or x is greater than or equal to a third. This tends all the way to positive infinity. If you're struggling to understand set builder, let me go through some interval notation with you in case you prefer this method. So all the way to negative infinity, remember we can never include infinity. All the way to negative 3, we would close the bracket, or alternatively, close the bracket again, a third. We're just using our stationary points from the first question. And that is it. Okay, the values that are strictly increasing, utilize your stationary points. The negative value is going to tend all the way to negative infinity, and the positive value all the way to positive infinity. And that's it. That's the entire question.